Okay, up until this point, in section 7.2 and 7.3, we were talking about trig functions of right triangles, meaning we were only concerned with those angles that could be part of a right triangle. And so the only angles that can be in a right triangle are acute angles. So if this is our right triangle, we know that this angle here is between, has to be greater than 0, and it has to be less than 90. And that this angle, I guess we'll call it gamma, when we add it to theta, has to be 90. So we were constrained by this in section 7.2 and 7.3. In section 7.4, we talk about trig functions of any angle. All right. So what we're going to do here is we're going to start off with, we're going to start putting these things, our triangles, onto the coordinate plane. Okay, so we're going to start putting our triangles onto the XY plane, and we're going to start, we're going to have this angle here at the origin that's going to come out, and then the angle that we're going to talk about is the angle that's created from the line and the x-axis. So we're going to call this alpha today. And we're going to have this point be 3, 5. Okay? So that's the x part, and that's the y part. Okay. So that means that this side goes out from 0 to 3. So the length of this side is 3. The length of this side goes from y0 up to y5, so that side is 5. This side is going to be the basically the hypotenuse, or the radius of this, whether we think of it as a circle or a triangle. It's going to be the hypotenuse of this right triangle. So we get 5 squared plus 3 squared equals 25 plus 9 equals 34. And so we call it R when we put it onto the plane. It's going to be the square root of 34. Okay, so now cosine is going to be adjacent over hypotenuse. So here's the angle. This is adjacent. So we get 3 over the square root of 34. Sine alpha equals 5 over the square root of 34, and we continue on with our others, although I've run out of room. So let's get a new page. And let's get a new point. Let's make this point 1, 9. So find the 6 trig functions for the angle created by having going through the point 1, 9 on the radius, or the hypotenuse. Okay, so this is the y part, so it's 9. This is the x part, so it's 1. And so we get 9 squared plus 1 squared equals 82. And we take the square root of that. That's our R, or H. Now I'm going to call this alpha. So sine alpha is opposite. That's going to be opposite over hypotenuse. Cosine alpha is going to be adjacent, so that's the 1. We have tangent, which is opposite over adjacent. And then we have cosecant, which is the reciprocal of sine. We have secant, which is the reciprocal of cosine. And we have cotangent, which is the reciprocal of tangent. There's our 6 trig functions. Okay, now what happens if our the angle created is more than 190, or more than 90, 190, more than 90? So let's say we have this point. This is a positive x of 2 and a negative 5 on the y. Okay? And we want to find this angle. Okay, so here's what we do. We still have this kind of triangle, and this is called a reference angle. And so, but we'll talk more about that next time. So let's see, this side from theta is -5, and this side is +2, and we still need this radius or hypotenuse. So we get, now whenever we square a negative number, it's going to come out to be positive. So no matter what, I'm always going to get a positive number here, because it's going to be, even if I'm squaring a negative number, it's going to be positive. So I don't have to worry about the negative parts. So I square them, add them together, and then take the square root. Okay, so sine alpha is going to be opposite over hypotenuse. So that's -5 over the square root of 29. Cosine alpha is going to be adjacent, so that's 2 over the square root of 29. Tangent is opposite over adjacent. And what we see is sine and tangent are negative here when we have this angle, and cosine is positive. So during class, you're going to be given a point in each quadrant to find the 6 trig functions, and then you will make a table that tells you which trig function is positive and negative in each quadrant. Okay, so this is quadrant 4. And in quadrant 4, we have sine is a negative, cosine is positive, and tangent is a negative. In the first quadrant, we have they're all positive. Okay, so on your handout on class, you will have the point -4, 3. And so you'll want to find the 6 trig functions of alpha. So we make the reference angle theta. This opposite side, that's y, and that's -4. So our radius, or hypotenuse, is going to be 4 squared. It's going to be -4, but Okay, so when I'm finding the hypotenuse, I just ignore the negatives. So I'm going to take 4 squared plus 3 squared. So 16 plus 9 equals 25. And then, well, that's r squared. So r is going to be 5. And r is always going to be positive, okay? Always positive, because it's related to distance. Okay, so this is going to be the opposite side, and this is going to be the adjacent. See, opposite, adjacent. And so sine of alpha is opposite over hypotenuse, or radius. Cosine alpha is adjacent, so that's minus 4 over 5. And tangent is opposite over adjacent, but we can just write that as minus 3/4. Okay, so that's the main 3, and you can find the other ones. And so we see in quadrant 2, sine is positive, cosine is negative, and tangent is negative. And so if you look, when you get your handout in class, you can see that quadrant 1 and quadrant 2 is filled out. You have 2 exercises to do on your own to fill out quadrant 3 and quadrant 4. Okay, the next thing that comes up is finding a trig function, finding the other 5 trig functions given some information about you know, some information, but not all information. So here we have sine theta equals minus 5/7. And we're also told that cosine is positive. So when you have your sine table, you consult the sine table. Sine is in S-I-G-N, positive or negative, not trig function sign. So you consult the positive and negative table for the 4 quadrants, and we see, okay, so we look for where sine is negative, cosine is positive, and we see that that's in quadrant 4. Okay, so I have sine. I'm going to need to find cosine, tangent, secant, and cotangent, and cosecant. Okay, so cosecant is going to be the reciprocal. It always has the same sign. Now the others, when I look at the sine table, positive or negative, cosine is positive, secant's going to be positive, tangent in that quadrant is a negative, and so is cotangent. Okay, so now I can not worry about the negative. What I need to find is, I have the hypotenuse. What I need to find is the adjacent side. So this is the opposite over hypotenuse. So I need to find adjacent. So 49, 7 squared minus 5 squared is 24. So the opposite, or the adjacent side, is the square root of 24. And so if we have opposite over adjacent, it looks like that. And notice, so once I only use this sign to figure out what quadrant I'm in. And after that, I don't use that sign anymore. I just get the numbers and plug them in like I did in section 2, or I think it's section 2, where we found the trig functions, but it was for a triangle, a right triangle, not a quadrant angle, or an angle all the way around. Okay, so that's how we find and fill out the other 5 trig functions given information about one. Okay, now we're going to talk about finding an angle. So if I have alpha equals 150 degrees, I need to find the 6 trig functions for that. So I begin this process by drawing 150 degrees. So it's roughly like that. Okay. Now my reference angle is always going to go from this terminal side down to the x-axis. So it's either going to go to the negative x-axis or the positive x-axis, depending on where I'm at. Okay. So notice that if I have this angle, the reference angle, and the angle I'm given, they add up to 150 degrees, or 180 degrees. So if I have 180 minus 150 gives me 30 degrees. So this must be 30 degrees. That's what it takes to complete the half circle over here to the negative x-axis. Okay, so basically now what happens, now that I have my first quadrant reference angle, sine 150 is going to be the same as sine 30, which is 1/2. Cosine of 150 is going to be, now in quadrant 2, cosine is negative, sine is positive, so I didn't do anything here, but here cosine is negative, so cosine of 150 degrees equals minus cosine of 30 degrees. And cosine of 30 degrees is 3 over the square root of 2. So cosine of 150 degrees is minus the square root of 3 over 2. Tangent of 150 degrees. We're in quadrant 2. Tangent is negative. So tangent of 150 degrees is equal to negative tangent of 30 degrees, which is minus 1 over the square root of 3. Let's see. Let's do 120 degrees. So I find the quadrant angle, or the first quadrant reference angle. And so I have 180. So I have 120 here and 60 here. So together that makes 180. Okay, so sine of 120 equals sine of 60, which is equal to the square root of 3 over 2. Cosine of 120, since we're in quadrant 2, cosine is negative. It's cosine of 60 degrees, which is 1/2. Tangent of 120 equals minus tangent of 60 degrees. The tangent is 60 degrees. Oh, I think I left off the negatives. That's supposed to be negative. Negative tangent of 60 degrees, which is square root of 3 over 1. All right. Okay, let's look at 210 degrees. All right, so this is going to go to the negative x-axis. So I need this angle. Okay, so I have 180 here. So 210 minus 180, that's like how much that is. And that is 30 degrees. So the first quadrant reference angle is 30 degrees. So sine of 210 degrees. Now we're in quadrant 3. So in quadrant 3, sine is negative. So we get negative sine 30 degrees. cosine of 210 degrees. We're in quadrant 3, so cosine is negative. So we get negative cosine of 30 degrees. So it's going to give us negative square root of 3 over 2. And tangent of 210 degrees. Now in quadrant 3, tangent's going to be positive. So we get tangent of 30 degrees, which is 1 over the square root of 3. And we get the other 6, or the other 3, sorry. So the first steps are to find the first quadrant reference angle. So if we're in quadrant 1, it's just the angle. If we're in quadrant 2, what happens is I go down to the negative x-axis. So these two angles are what we call supplementary. So we take 180 minus the angle that we are given, and that's going to give us the reference angle. In quadrant 3, that's down to here. Okay, in quadrant 3, we're still going to the negative x-axis, so there's 180. So we take whatever angle we're given and subtract 180 degrees, and that gives us our reference angle. And then in the fourth quadrant, we go to the positive x-axis, and altogether the given angle plus the reference angle is going to equal 360. So it's 360 minus whatever angle we're given to get the first quadrant reference angle. The last thing is coterminal angles. So if I have an angle that's like this, that would be 750 degrees. So the coterminal angle would just be right here. So I subtract 360, and I'm actually going to subtract 360 twice because I go around twice. And that is going to give me 30 degrees. So all of the trig functions, sine of 750 is going to be sine of 30 because the coterminal angle is 30 degrees. And then repeat for the other 5 trig functions. Now I could do something like this. We'll call that well, let's see what happens if we call it 500 degrees. Okay, so I go around once, so I take off 360, and that gives me 140. So that means that the coterminal angle is 140 degrees. So sine of 500 degrees is going to be sine of 140 degrees. Now it's not a special angle, so I can't take it any further. But that's the idea. When we have a coterminal angle, we find when we have an angle that's more than 360 degrees, and we can go backwards too. We'll talk about that in just a second. But when we have an angle that's more than 360, we get it down to something between 360, and that's our coterminal angle. Then depending on where we are, we may need to find a first quadrant referencing. Now, I can go this way. This is a negative angle. Whoops. This might be negative 30 degrees. So the reference angle is easy. as far as the first quadrant reference angle, it's just 30 degrees. Now the angle that's between, going around this way, it would be 360 plus a negative 30, 330 degrees. So that's how we would find the coterminal angle if we restrict it to between 0 and 360. But the reference angle, when it's negative, it just means we're going this way. And if it's in the fourth quadrant, we just remove the negative sign and remember that we're in the fourth quadrant. And so all the things that are negative in the fourth quadrant, positive and negatives are positive and negative there.